I think we'll go ahead and get started with our introduction here. So again, thank you everyone for joining us this evening for tonight's program. So welcome to Understanding Extreme Weather and Climate Change with Bexley Public Library. My name is Jeff. I'm an adult services librarian, and fellow BPL staff member Leanne is also in the Zoom meeting. She will be doing behind the scenes work. And finally, a few words about our speaker this evening. So Ben Gelber is an Emmy award-winning meteorologist who forecasts the weather for NBC4 each weekend at 6 and 11 p.m. and a science and environmental reporter 3 days each week. Ben was awarded an Emmy for Best Weather Anchor in 2007 and has received several Emmy nominations. He earned honorable mention for Ohio's AP Best Regularly Scheduled Weathercast in 2003, first place for Outstanding Weather Operation in 2000 with his Storm Team 4 colleagues. Ben holds a Bachelor of Science degree from Penn State University and a Master of Science degree in Meteorology from Northern Illinois University. He was awarded the American Meteorological Society's Seal of Approval and inducted in the East Stroudsburg High School Meritorious Hall of Fame. So thank you so much for being with us this evening, Ben. I'm going to pass it off to you.
Thank you, Jeff, and thank you, everybody, Ann, Kathy, William, Michael, and Jean, and Sandy, Dick. And what I'll do, because I certainly want to hear from you guys as well regarding any questions, I'll talk a little bit about what is topical following the headline, of course, was extreme weather and climate change, and then talk a little bit about what we think might happen this winter with all the usual disclaimers. But hopefully we'll have plenty of time for any questions that you have, and it's just meant to be an overview. You know, the things that jump out this year, we've talked about, and you're obviously well aware of, are the historic wildfire season in the West, unlike anything we have on record in modern times. A historic hurricane season in the Atlantic Basin, unlike anything we've seen with records going back into the middle 1800s. We have to distinguish between, and this is the most difficult portion of the climate science, natural variability versus what may be driven by what we are observing, which would be higher air and sea surface temperatures. So the question is, what do we know for certain? There's a lot of information out there, and there's some debate, as there always should be, and there often are conflicting views, which is not unusual either. When you study the science of climate meteorology, I was surprised at some of the heated debates that went on back in the 18th and 19th centuries over climate change and how storms developed among some of the science luminaries of the time, including our founding fathers, who debated whether climate change was real in the late 1700s. So what's old is new. In the short term, what we look at are what is happening that is kind of beyond the pale. In other words, so much weather can be determined to be natural variability, random variations driven by measurable forcing factors, whether it's solar activity, solar radiation from the sun, which is also to a very small degree cyclical, slow moving changes in ocean circulation and temperatures, and what's pertinent to this winter, El Nino or La Nina patterns. But what it comes down to, I think, and where the science is clear, that would be the physics. And what we know is a warmer atmosphere has a higher capacity to store moisture. And that is turning out to be, I think, the driving force behind not only, and not necessarily more hurricanes, but what I think the most interesting research based on climate modeling, as well as observational evidence, would be slower moving and faster developing tropical cyclones. And typically they're already at or near hurricane stage when that process begins. We have 30 storms, and just today alone, or as of last night, we saw the landfalling storm Theta, which became the strongest storm of the season yesterday with 160-mile-per-hour winds, the first Category 5 hurricane in the Atlantic this year. And it came in as a strong Category 4 when it hit Nicaragua within 15 miles of where Hurricane Eta struck with 140-mile-per-hour winds roughly 2 weeks ago. And that, of course, devastated portions of Central America and eventually wound up back in the Caribbean and the Gulf, and had a couple of several additional landfalls, including Cuba, along the Florida Keys, and then near Cedar Key, Florida, which played out last week as a much weaker storm, but still a potent storm. But the key elements here are storms, and this is the 10th instance of a hurricane that rapidly intensified. And by that, and I'll go with the formal definition from the National Hurricane Center, is an increase in winds of 35 miles per hour or greater in a 24-hour period. So, of course, this has always happened, but we're just seeing it happen more often. And this year, we now have had 10 storms fall into that category, tying 2005, which was the record we broke when we, with Eta and Theta. 2005 produced 28 named storms. We're now up to 30 and counting. The number of rapidly developing tropical cyclones, whether it's from tropical storm to hurricane strength or already as a hurricane, is due to one reason only, and that is, or two reasons really, would be warm water and a lack of wind shear. And that would be strong winds aloft that tend to disrupt storms. So absence of wind shear, and then most importantly, the fuel, and that's the physics, the fuel comes from warm water. And warmer air not only fosters a warmer sea surface, but it's what we're finding out is the depth of that warm water is extending farther down. And that's important because that means instead of overturning the warm water and then pulling up cool water, which was a natural lid of sorts on storm development, storms can have a deeper reservoir of warm water to draw on. And then a related study has found in recent decades that storms move over land are weakening more slowly. And that may be completely related because the storms themselves are stronger, but also the storms appear to be moving more slowly, which then the degradation process, which is friction slowing the maximum winds and to some degree limiting the inflow of moisture over time, if that process takes longer to happen, let's say a storm on average, at least according to the study, may have lost 3/4 of its wind strength in 24 hours, maybe only loses half of its wind strength in 24 hours. And that might be a storm that has made landfall with 120-mile-per-hour winds. So that could be a big deal. Maybe a more larger swath of the usually the southeastern United States is now dealing with stronger winds and rain even heavier or more prolonged than what might be expected. And so that the implication would be greater flooding threat, which is usually our biggest concern, inland flooding with these storms, because usually the winds have wound down at a certain point. But obviously at landfall and short distance inland, winds are also a big deal. And perhaps the biggest deal would be a storm surge, which tends to be higher with more powerful storms. So when we circle back to what has changed, and regardless of how we assign reasons, what is not up for discussion is that the air is warmer and the water is warmer, because we can measure those variables with great accuracy, precision at the surface and with satellite measurements. And we have enough of a record now with satellite measurements back into the 1960s, and with snow cover analysis back into the late 1970s. That while there was a legitimate concern as far as the data quality farther back in time, for obvious reasons, technology, we are very comfortable with the information. We can draw these conclusions. So that's one aspect of climate change, regardless again of what's driving that, and that's a longer discussion, perhaps. But climate change impact on tropical cyclones, which would be everything from a tropical depression through a tropical storm to a hurricane. And then the other, at the other end of the country, in this case, the southwestern and western United States, going through the worst wildfire season on record. That's obviously clear cut. It's drier, it's hotter, and then when you factor in, depending upon where air pressure systems reside, stronger winds, and then we had a freakish occurrence in San Francisco, or in the Bay Area, where you had somewhere around the 25th or so of August, a rare cluster of thunderstorms, which were probably fueled by some warmer than average water in the Pacific, or a more vigorous storm than you would expect to see in August off the coast of California. That sparked thousands of wildfires caused by dry lightning, not by, say, human carelessness or a spark from a power line. So these are things that we can quantify and that are telling, because we know we can measure the fact that it's gotten hotter and drier in the southwestern states, and that creates conditions more favorable for what has transpired. And then you potentially have stronger storms or clusters of thunderstorms in areas that normally wouldn't have that kind of weather, that triggered the lightning strikes that in turn sparked fires. And I did a story, or was interviewed by the New York Times on fire tornadoes, which have existed before, but we also had an instance of an exceptional fire tornado in terms of intensity. And we're talking about things that are a little farther off the edge of probability, but we clearly can link that to whether it's temperature extremes or precipitation extremes, whether it's on the dry end or the wetter end of things. One thing we know locally, and by locally I mean the Ohio Valley, is the climate has gotten warmer and wetter. That also that's very easy to measure, because we have longstanding weather stations, and we have seen in this past decade, we'll say 2011 to 2020, this is the warmest and wettest on record. And we do have good records back into the 1800s to be able to say that, not just us, but but the entire region, and in most regions, certainly in the eastern half of the United States. And as I mentioned in the beginning, warm and wet, at least in the eastern U.S., go together because of proximity to moisture sources. So you can be warmer and drier than average, as is the southwestern United States, and part of that is led to what appears to be the longest standing drought, and going on 20 years now for portions of the Southwest, maybe in the past millennium. So that's a pretty big deal. So that's where the climate science intersects with historical record keeping, and climatologists who look at long range, and meteorologists like myself, although they're obviously closely related, look at short-term and medium-term forecasts. But it's the melding of our knowledge that is giving us a raft of studies that things are starting to line up where we begin to, I think we can begin to draw conclusions with a little more confidence. And that's not to say that natural variability in all these elements is not still very important. So we have to be careful with that, like the mantra, one weather event or one season or 1 year does not tell us anything in of itself. But when you see clusters of years, clusters of storms, clusters of droughts, where we don't have a history of that, at least a modern history of that, And we do have good climate data extending back hundreds of thousands of years by proxy. Then you begin to weigh in, what has changed, and that's for a particular branch of our field to parse. But that's one aspect of what we're seeing just right in front of our eyes on the news every night, what's playing out, and it's obviously a little bit daunting, realizing that we may have shifted into a particular climate pattern that may be more consistent, which might mean, as we've seen this year, a record-tying number of billion-dollar disasters. So the ramifications aren't just, oh, it's a little hotter, it's a little wetter, a couple of extra strong storms, but I mean, the human toll is substantial financially and in terms of potential loss of life. So, and if you're an emergency planner, whether regardless of the odds or regardless of how much is human activities, such as burning coal, oil, and natural gas and transportation versus how much is just simply just natural variability, that we may be in a warm or cold cycle or a wet or dry cycle that has come anyway over the years. If you're an emergency planner or that, in one case that's very important, rising sea level, it's a big deal because it doesn't matter the cause. You have to plan for a new normal, and even for the 1 in 100, or in this case, maybe what we're seeing with both flooding and with the number of storms, as I mentioned, hurricanes ramping up, maybe something that would have been a 1 in 100 year flood or a 1 in 500 year flood happening more often, and maybe significantly so. Maybe what would be a 1 in 50 year number of hurricanes, or 1 in 25 year occurrence of number of hurricanes that intensify rapidly with all the implications of potential damage and flooding and potential loss of life and property, suddenly is happening once every 10 years. So these are all very real areas of concern and study. So that's part one of what I wanted to talk about. And then I always get asked probably 1,000 times over, just like I did as a kid, what kind of winter can we expect? So I'll post a few graphics and comment on that, and then hopefully we'll address some questions. So regarding and a lot of folks follow the almanacs, the Old Farmer's Almanac and the Farmer's Almanac, and they are two different almanacs. The Old Farmer's Almanac probably gets a little more traction, and that's the one with the yellow or gold cover. But the same idea. But as a kid growing up, I always couldn't wait for the almanac to see if you could get draw a bead on what was going to happen in the wintertime, as far as snowstorms and stuff that got me into weather in the first place as a kid. But we do have NOAA, the Climate Prediction Center, CPC, putting out reasonably good 3-month outlooks. And based on the projection of temperature for the core winter months, December through February, the expectation is, at least for the upper Ohio, well, essentially for the Ohio Valley, south and east, warmer than average temperatures, and for the Pacific Northwest, Northern Rockies, Northern Plains, and portions of the upper Midwest, colder than average. That doesn't mean through the whole winter. Again, that's just average. Now, our next slide regarding precipitation is interesting. It would suggest the southern half or southern portion of the United States would be drier than average, and the north would be wetter than average, except equal chances. That's what EC stands for, 50-50, or not determinate for the Northeast, and of course on the margin. But clearly the Ohio Valley, except maybe the upper Ohio Valley, is in the high end of above average precipitation. But that could also be, that could be rain, that could be snow, that could be both. That hinges on the storm track, which clearly the storm track would have to be in our vicinity, such as along the Mississippi and Ohio River valleys, or along the west side of the Appalachians, or across the Great Lakes, for this to work. It doesn't mean we have storm after storm after storm, or that we don't have dry periods. Again, this is just meant to be an average. So the National Weather Service in some would be milder and wetter than normal. for the Buckeye State and the Midwest. So what, as we go to slide number 3, what is that based on? Of course, there are multiple factors, but the driving feature for this winter, which was not present last winter, would be La Nina, cooler water in the equatorial, central, and eastern Pacific, which would be the very bottommost portion of the screen. But that in turn impacts the jet stream because the air-ocean interface, that's where weather occurs, or at least that's where moisture is drawn upwards into the atmosphere. So looking at past La Nina seasons, especially a moderate to strong La Nina, we tend to have blocking high pressure that's more persistent than not south of the Aleutian Islands. So what that does is it pushes the jet stream a little bit to the north, and that's a reflection again of cooler water down what would be the bottom of your screen. If we could show, if you picture basically the bottommost margin, but we tend to see high pressure develop obviously north of the Hawaiian Islands and south of the Aleutian Islands, and the Hawaiian Islands in the lower left. So if you follow the jet stream in that kind of pattern, you have an opening underneath high pressure for low pressure to move into the Pacific Northwest. So you see all the way down to Northern California, wetter than average weather. And then the jet stream, because there are natural waves in the jet stream, it doesn't stay up in one position. So it buckles in the northern plains, or at least begins to tilt southward. So the cold air would spill naturally into the upper Midwest. So that makes sense. But then the next buckle in the jet stream would be over the Ohio Valley. And of course, storms follow the jet stream, and the boundary is the active weather pattern with warm air to the south of the jet stream, cold air to the north. But if we're right on the boundary, we would be in the thick of more frequent storms. And with that kind of storm track, we would probably favor rain over snow in some, if not majority of storms, but not necessarily all. But the other takeaway is that it's harder to draw Arctic air for any length of time in Ohio. And that usually requires a partial visit from our friend the polar vortex, or at least a deeper dip in the jet stream. So the upshot is that this would be one of several factors, and that will help determine what the bulk of the winter would be like, not all of it. But there is still always a question mark in slide 4, and that again has to do with what does the polar vortex decide to do? So when we look at the next slide, we look at Atlantic pressure patterns, and the Atlantic pressure patterns determine whether the cold air is transient or whether it sticks around or has a chance to die farther south. So if we get the equivalent of a blocking high pressure ridge, say over the North Atlantic, and that would be in the image on the right, what we call a negative Arctic oscillation. If we tend to get a blocking pattern with a weaker polar vortex winds, or the winds that circumnavigate the highest latitudes, then that flow the dam is not as proficient at holding back the cold air, and then pieces of cold air or the vortex itself push south. So the picture on the right, which is independent of El Nino and La Nina, again, this is now the Atlantic air pressure pattern. So the picture on the right would favor periods of cold and snowy weather, and you can have both going on in a wintertime. The graphic on the left with the colder stratosphere and stronger winds associated with a colder stratosphere in the polar regions, that tends to trap the coldest air. So on the left-hand side, if that becomes the predominant pattern, which would be a positive phase of the Arctic oscillation, the cold air is shunted from Canada across maybe the northern tier, and then through the Canadian Maritimes, and then over toward Western Europe, which in turn has a wetter than average winter. So we tend to get, long story short, glancing below when it comes to Arctic air masses, or more, in and out cold, then you're less likely to link up with Gulf moisture and get big snowstorms. The picture on the right, which would be the negative Arctic oscillation, which is a weaker polar vortex or polar circulation, which in turn means that there are bigger dips in the jet stream. The barrier is not as strong that would hold cold air north. Well, as that breaks down at times during the winter, some of that has to do with what actually is happening way up in the stratosphere, and 30, 40, 50,000 feet, when you get quick warm spells and the polar vortex gets dislodged down below. And again, the polar vortex is not a ground feature. It's essentially high latitude and high altitude cold air, coldest air in North America. So that's the link to the stratosphere. But when there's a breakdown as the winds weaken, then cold air can spill farther south. And the net effect is Western Europe is colder, and then that also means more moisture for, say, the Mediterranean region, North Africa, and Southern Europe. Everything is globally linked. And beyond the scope of this talk, there are other features such as Pacific oscillation that is strictly in the tropics and involves patterns that originate in the Indian Ocean with clusters of thunderstorms that move across the Pacific Ocean and then on farther east that create up and down motions in the atmosphere. And when things are going up, you have rising motion, you get stormier weather. And so a stormier phase having to do with that cycle, which is yet another cycle in the mix, can help determine whether we get more storms coming out of the Gulf, for example, or up the eastern seaboard, or if we're in a drier phase during the heart of winter, then we don't get the snow. So, just to summarize, you have El Nino, of course, is the opposite of what we are seeing this year. La Nina is the cold water pattern. Several years ago was an El Nino, which is warm water in the equatorial Pacific, and that would be a flip of the pattern we see this winter, in which case then we would have wetter weather in the southern states and drier weather in the north. But it gets complicated by Pacific, Atlantic, and then you throw in a separate oscillation that originates in the Indian Ocean that helps drive the jet stream positions, and you can see why there's a lot of that goes into the mix. To a much lesser degree, variable solar activity, literally heat from the sun, and like turning down a thermostat. Maybe if there's a little less solar radiation, that in turn affects energy going into the upper atmosphere, which in turn affects the stratosphere, which is where the ultraviolet radiation is absorbed by ozone, which in turn affects waves down where we live. And so these evaluations occur throughout the winter, but all of this is cyclical, and that part climatologists put together to create long-range forecasts. And there's just simple, straight variability. Last year, case in point, we didn't have an El Nino, we didn't have a La Nina, we had a neutral pattern, and we didn't have much in the way of blocking in the Atlantic, and we actually wound up with a very mild winter and less than a foot of snow, and a top 10 mild and least snowy winter. And yet it began with our heaviest snow of the season coming on Veterans Day last year. So again, there's so much in this, but this is what these factors go into our winter forecast. So I'll take a pause here to see if you guys have any questions, or folks from Bexley Public Library have some questions that they had going into the discussion. And by the way, feel free to ask anything that might interest you regarding either the subject matter or, and maybe while we'll wait to see if there are any questions, I can add that, I've been at this now 40 years, coming out of Penn State and then getting my master's degree, and how drastically different things are when it comes to television presentation, when it comes to high resolution models versus low resolution, how much more we know, that the 3 to 5 day or 5 to 7 day forecasts are now as accurate as the old 1 to 3 day or 2 to 4 day forecasts. The technology with Doppler radar allowing us to see rotation in storms that didn't exist when I started, even merely animating some of these features on air. We can X-ray a thunderstorm. In the old days, we had to wait and see if someone called in a report of a funnel cloud, often to trigger a tornado warning. But now we'll see rotation. The Weather Service will issue a tornado warning, and we'll put that on the air immediately. All right, I'll pause again to see.
So Ben, it looks like we have a question. Jeff lost internet, so I think he's popping back in, but we have a question from the audience from Kathy. And she asked, her husband John wants to ask, which weather-related events across Ohio cause the most damage in terms of cost?
Yes, thanks, Kathy, for your question. And I would have to say, when you look at some of the massive tornado events like Xenia and the family of tornadoes in April 1974, that was based on current costs over $1 billion damage. When you look at the remnants of Hurricane Ike in 2008, that caused, I believe, over $1 billion damage in today's dollars. So in one case, it was a tornado outbreak. Another case was a freakish windstorm. But actually, the costliest event would have been the 1913 flood. That also took more lives than any single weather event, both in Columbus and state of Ohio. Officially, I think 467 fatalities, and quite possibly much higher statewide, and roughly 100 died in Ohio from historic flooding. That would actually exceed the Xenia tornado and the Ike windstorm, which caused enormous millions to lose power. The derecho in June 2012, which was a pure windstorm but driven by thunderstorms, also is in the upper range of the chart. So, it depends. I mean, when you have moderate to significant flooding, you will wind up with maybe tens of millions of dollars damage. The blizzard of 1978, there wasn't so much structural damage, but the huge cost of transportation issues, to heating, to engaging the National Guard, and so I mean, across the board, obviously, devastating wind events seem to cause the costliest. But if you get an extraordinary or nearly statewide flood event like 1913, but usually flood events are much more localized than that. That can be a close second, and you get a superstorm, a storm of the century, winter storm that took 50 lives or so in Ohio, and caused untold hardships. So those are some of certainly the most significant events.
Thanks for illuminating that, Ben. Sorry about the internet drop there, everyone. I'm back, and hopefully that will not happen again.
I'm gonna grab my drink right next to me.
So yeah, this question actually is coming from me. Oh wait, do we have one in the chat here? Okay, actually, let's go to the one in the chat then. So Kathy says, what might be the most costly event in the future given climate change?
Well, we know that we can't attribute tornadoes to climate change, at least not directly. That might be the weakest connection, although certainly warm Gulf water, or Gulf water that is warmer than what you might expect, without the changes, that is certainly fuels storms. So of course, everything in weather is interconnected, but it probably would not be a tornado outbreak. And we certainly had our super outbreaks all the way back to the 1800s, and it did enormous damage, just that the country was more sparsely populated. Flooding, again, we've had major floods that we dare not attribute to climate change, because there's so many parameters involved. So something that would, so that's where it gets a little trickier. As far as locally, I mean, in our part of the country, You know, I don't know that, I think that would be tougher to ascribe climate change in terms of something unlike, you know, those are regions directly affected by hurricanes or exceptional drought, but we're not in either category. Yes, we do get remnant storms, but in virtually all cases, with the exception of Ike in September 2008, those remnant storms are heavy rainmakers. But arguably, you know, maybe these storms stay stronger longer. And we saw earlier this year, Cristobal get all the way, get farther north and west and farther north into Canada than any remnant tropical storm has ever traversed. That went straight north up the Mississippi Valley. And then eventually the remnants turned east, and I believe it triggered a tornado in western Ohio. So if these storms are stronger and holding their strength longer as they come into, we'll say, the Gulf states, and then they maintain that, and that we know is a product of warmer water and warmer air temperatures, well, then the impacts extend farther north than we might expect. So if there is an impact, it would probably, but not be a severe impact, would be a remnant tropical low. But of course, you could wind up with moderate flooding. We even saw that with Frederick in 1979, that came up into the upper Ohio Valley and dropped 4 to 7 inches of rain on central Ohio before I came here. But my colleague told me about how bad the flooding was then. And so if we have more opportunities or higher probability of stronger storms or storms remaining stronger, the remnant tropical lows being more impactful in Ohio, that might be an example of climate change directly here in Ohio in terms of storms.
Yeah, well, I guess, you know, one way we can sort of feel lucky here in Ohio and Midwest, we are not as impacted by some of these things you're describing. Yeah. So next question here. Do you have any recommendations for organizations to donate to or policies to pay attention to for the average citizen that's concerned with human impact on climate change?
Yeah, that's a good question. I mean, there's some, you know, and I realize, you know, much to our frustration, some of this gets politicized. So I don't want to, and I never want to step on anyone's toes as far as what one thinks of, say, environmental organizations. You know, folks do great work, though, at literally at ground level in terms of water and stream pollution. And I should put out there that when it comes to a cleaner environment, that never should be part of the debate. And I understand there can be differences in opinion regarding regulations, but you can't argue against better water and air quality because that directly affects our health. So anything that works to to keep the air and water cleaner, and that even started under President Nixon, who the formation of the Environmental Protection Agency and the Clean Air and Water Acts in the early 1970s, and there was pushback then, but no one complains now about that. I think, you know, being good stewards of our environment, obviously, I believe is not a political issue, but that, and the benefit is that you know, what keeps the air and water cleaner usually helps reduce pollution and our carbon output as well. So, you know, if you're so inclined, and again, you know, all this is all very personal, but you can look into organizations if that is something you're interested in, that work toward in my view anyway, a cleaner, healthier environment. And there are plenty out there, and that dovetails with health matters and health organizations too. And then, you know, as I'm a guest lecturer at Ohio State, and I will be likely an adjunct next fall. And I've taught at Columbus State, and I also visit the schools at all levels. You know, I remind students about just being discriminating readers and viewers of television. But you know, the smarter we all are, and then you know, in terms of being understanding terms that appear in science stories, and which helps us better understand and process what are real threats versus what might be something that's hyperbole or political. All of that is good. So anything involving educational resources in terms of our grassroots involvement, whether it's through the school systems or just being active in community organizations that promote, again, as I said, clean air, clean water regarding the things that we've been talking about, I think are a good way to go. And just on a personal level, because we all have family and friends and children and grandchildren, the more attuned we are with better information and good resources, youngsters and young people take cues from us, just as I took cues from my parents and grandparents. So, and then they may go on to careers in either science or just awareness, or it may come down to your choices during these various election seasons, based upon whichever way you want to go is fine. But it's just being more knowledgeable and more discriminating and understanding and separating good information. And my job is, as a science reporter as well as a meteorologist, to put out the best science out there. That involves talking to the top scientists at our local universities. Ohio State is a repository. You just may have seen the story in the dispatch for all these 3-foot-long ice cores that, from taking our climate studies back 800,000 years in a 30 below zero Fahrenheit refrigerator. But that's how we can actually determine what, for example, carbon dioxide levels were like at other times. Does that match up with temperature patterns or not? When was it drier? What kind of vegetation grew, which may be a clue as far as drought cycles. We still need this wealth of data, and that comes from universities, and Ohio State is right here in our backyard doing all of this work and among the best in the world at that. And I did a class where we linked up with students in China and exchanged ideas, and I led that discussion through a class at Ohio State. So there's so many ways to, again, I just believe in promoting good science education and understanding each other's viewpoints, which are obviously can be quite varied. And I encountered that in my presentations, and I think that's great. I think lively discussions are the way to go.
Absolutely, yeah. And I feel like I should just echo what you said towards the beginning there is, cleaner air, cleaner water, protecting our environment really isn't something that should be politicized. It should be something that is just a priority regardless of your affiliations. And I feel like we've seen, this sort of ties into the next question we have here. We've seen things politicized during this year, particularly during the pandemic, that maybe should not be. So yeah, I see what you're saying there and support it. So the next question here. So have changes in human behavior during the pandemic, less travel and things like that, has that impacted climate change in any meaningful way, you think?
Well, it's interesting. We saw, and because I do science features when I can, we saw how nitrogen dioxide levels dropped with the sudden with various shutdowns, partial closures globally in particularly metropolitan areas. We saw the air get cleaner and clearer with less cirrus clouds when air traffic came way down for a short time. We saw ecosystems, whether it be fish or birds and other animals, returning to places where they hadn't been seen before, or in a long time, or in fewer numbers. So it was kind of like a bit of an experiment on a global scale. So certainly, we just because of the adjustments that we've had to make, or just the fact that we can't travel because of restrictions, we've already seen changes in the environment. And then, of course, a bounce back when some of those restrictions went away or were partially taken back, or people felt more comfortable traveling. So now, and I just talked to an OSU environmental engineer for a little piece I'll probably do this weekend on talking about recirculation of air and improving air quality in your home coming into the holidays, because as we learn more about virus particles and as we know, it's airborne transmissions. That the cleaner the air is through use of higher quality air filters and opening the windows and things like that. Actually, that scientists can quantify how that is better for us. And of course, airlines are taking that into account too. And for that matter, commercial buildings, recirculating air and from between exchange between inside and outside air, maybe disrupts some of that, the potential for transmission of specifically the coronavirus. So these are all interesting discussions, both from a climate standpoint and from human health. And again, you cannot separate the two, in my view, nor should we.
Yes, absolutely. And, I feel that many of us have sort of had a crash course in things that you mentioned, such as air quality and aerosols and all these things now that are sort of household topics that, we never really knew about before, or most of us didn't anyway. So hopefully if there's any sort of, I guess, fringe silver lining to a very dark situation, is that maybe we can learn more about, having better air quality in your homes and just generally the spreading of viruses, not just COVID-19 going forward. So I wanted to open up to questions one more time. Does anyone have any questions? Submit via the chat. I think we're just had the one.
Yeah, feel free, and it doesn't have to be on the topics we talked about. Extreme weather or winter weather. If it's just a general, because I know when I give talks back in the traditional way, and we get wide-ranging questions, but happy to answer something before we wrap up, whether it's about television weather forecasts or accuracy, or how often tornado warnings are issued. In other words, it's anything that's weather. I'll give it a shot. And while we're waiting, I will say one of our, because I do get asked this a lot, one of our biggest challenges is how to handle severe weather. We break in automatically for tornado warnings, but the reality is we're going to sometimes suffer a little bit of pushback in the media in general, which is disconcerting, because our job is to get the information out. We hate to interrupt programming, especially a sporting event or a new a comedy special or whatever. But that's where it's challenging, I think, because we have the tools. We can recognize, and again, we don't issue the warnings. We relay the warnings that the National Weather Service issues, but we do have responsibilities, including mandated by the FCC, to put that information out on the air and immediately. The tricky part is working around, and I could see if I'm a viewer and there's a tornado warning for a county 50 miles away, but what we'd like folks to realize is that we are responsible for a wide area, and folks tuning in and out, and folks don't have access to weather information automatically. It's not a case of, well, everybody has phones or everybody can go to the Weather Channel or get it on. No, that's not the way this works. And we have to continue to, and we need the visuals, and we need radar, and we have to explore and analyze and tell folks, even if it's one county or if it's the whole metro area, who is in the path of danger that potentially saves lives, and that's again difficult. I always feel bad because I know we have to cut in, and it's less of a concern when it's a wide-ranging event like the extensive tornado, near historic tornado count on Memorial Day of last year. We had 21 tornadoes in the state, and just about every county, it seemed. And I was on there for about 5 hours straight, had tornado warnings in our viewing area. Dayton area got devastated, portions of Dayton, and we had our share of damage. But then you get the 1 or 2 county warnings and maybe nothing touches down, but the National Weather Service sees rotation. We don't know, and often they don't, if a tornado warning will result in a touchdown or where. So you have to broad brush. And I think how we have to stay on the air when the sirens are going off. We can't abdicate that responsibility, but it's always a trade-off. And of course, the trade-off is we use split screen coverage. That happened on Labor Day, but so that's one thing that's changed since I started in terms of how we handle severe weather. And we just had a windy event on Sunday, which I was able to highlight, for example, on Saturday with a wind advisory. But I would let every newscast with, bring in all your furniture and lock down your holiday decorations. Be prepared for, I said, winds of up to 60 miles per hour. So my job as a meteorologist is to put that out there when we can in advance in every single newscast, as well as all our social media platforms and radio broadcasts that I do. Put that out there in advance to alleviate that, so there isn't a surprise. Now, not everybody's going to watch or hear something like that, but especially with the advent of social media, if they may not catch you on TV, but they may see it on Facebook. And I do have a weather page under Ben Gelber that all our Facebook lives, which is great in between newscasts or for events that we wouldn't cut in on television for, like a wind advisory, but there's still important information. How long is it going to be windy? Where the wind's strongest, where's a particular storm heading? And then if it upgrades to a tornado warning, for example, then I leave Facebook, but my link, which is linked to the station, that feed continues to run with radar while I then switch to TV mode. But these are all operational things that I think we've gotten better at because it's all about safety.
Yeah, absolutely. And I know for me personally, I can't speak up for everyone, but it could be Game 7 of the NBA Finals, and if there's a tornado, threat in the area, cut it off. Please let me know.
Yeah, so and the problem is that some folks, unfortunately, a small percentage think, well, again, it's way out there. It's not affecting the Columbus area, but we hear from and not that is ever a factor in my decision making. Everybody counts, whether it's a rural, northern, or southern county or Metro Columbus. And that's, again, our responsibility, because in a classic example, in November 2002, I had to cut into NASCAR, which never works out well, goes over well, but we had rotation over Logan County, east of Bellefontaine, and I broke in. We even did split screen. I knew some folks were not going to be happy. But I said, if you live in Union County, which is now, we're talking 50 miles northwest of Columbus to about 30 miles northwest of Columbus, you essentially have to hit the deck. There was rotation with a hook echo, a tornado signature. And sure enough, and this was even a few minutes before the National Weather Service issued a tornado warning. What was, I believe, and they were F instead of EF scale, F3 tornado touchdown, destroyed a dozen homes. And I heard from the EMA, Emergency Management Agency director, the next day, and said that folks took cover. There were 2 serious injuries. They survived. They were literally tossed from their home into the mud. But because it was muddy, it was just an amazing story. And I met those 2 folks a number of years later. But folks took cover, but it was difficult addressing the fact that there were TV viewers who are angry that we had to cut in because it wasn't in the Columbus area, but of course Union County is our viewing area. So I have to make decisions that are not always popular, but we do what we have to do. And I hope that, in hindsight, I get the initial reaction, can't you guys wait, or can't we just run a crawl? But that doesn't provide the visual. And if you're in that specific county, you need to see where the storm is and how dangerous it is. And of course, when things weaken or back off, we can back off and then go back to crawl mode and cut in as necessary. So this is an intricate dance that we handle, and every situation is different. And the outcomes, many, if not the majority of tornado warnings, just, nothing touches down. Rotation is real, but just because there's rotation in the clouds doesn't automatically mean it's going to reach the ground. But when it happens, and if you don't have a warning, that's a worst case scenario.
Yeah. And again, something that has been reiterated this year in particular is, sometimes we have to make some sacrifices for the greater good. So yeah, a necessary service you're providing. So I want to get to, there are two questions that came in on the chat before we wrap up here.
Okay.
Michael Miller says, what causes high all day long high wind speeds like we have felt over the past few days?
Yeah, and the short answer to that is pressure gradient or difference in air pressure. In this case, and I remember I developed a graphic on Sunday night for the weathercast. Very strong, rapidly intensifying low pressure that moved the gales of November. You've probably heard that term. That tracked from the upper Midwest and Central Plains across Lake Superior. So that kept us in a strong corridor of winds on the southeast side of the low and the south side of the low. And now the pressure gradient isn't entirely the low pressure center itself, although that has a lot to do with it because air moves from high to low pressure. So air was racing in and up into toward the Great Lakes. We also have a strong high pressure area in the southern plains. So the pressure difference, it was like instead of a hill to a little shallow area to a depression, it was like a mountain to a valley, and air rushing from the mountain to the valley, high pressure to low pressure. So we had a very strong corridor of winds. Now, there are two things that happened Sunday. You had on the broad scale, that creates a day-long wind event because it takes a while for low pressure to track from the upper Midwest up into eastern Canada. And even residually, as the low departs and the high moves in, there's a surge of cold, dry air. And that air, because cold, dry air is heavier, is sinking, and then that hits the surface and splatters or rushes out. So winds are further accentuated by density of cold air. In other words, if the air mass coming in behind this system was lukewarm, let's say it was fall or summertime, or you wouldn't have that deep a storm anyway, you wouldn't get as strong a wind. So there's a couple of things: strong air pressure, pressure difference, but also called mechanical mixing of higher wind speeds from just above the ground, thousands of feet up where the winds are stronger and not unfettered by friction, working down to the surface and then pushing outward. So you had everything kind of maximized. And again, you had a particularly cold air mass. So there was more sinking air, more dense air to sink. And that resulted in the corridor of winds. But the other element, the winds were particularly intense with a squall line, which was a line of rain and embedded thunder just ahead of the cold front itself. And that caused clouds to get to a higher altitude, we'll say 15,000 feet. And so and then you have more up and down motion when showers and thunderstorms build up to a higher altitude. Well, some of that air comes back down that might have stayed up at this level. So you had a concentrated zone of winds in the 60 plus mile per hour range with the passage of that squall line that did most of the damage. 75,000 AEP customers or more, and another 11,000 South Central, and trees down and a couple of buildings damaged, and so on. So that's what was happening on Sunday. Kind of a lot of things ganged up on us, but very not unusual at all. And we'll have several days like that in the spring, in a normal spring as well. Just a little bit more likely in March and early April, but certainly not rare in November because of the increasing temperature contrast in the atmosphere.
So the last question here, what is the current status of the Western fires, and can you predict the future situation?
Yeah, the future situation is not good because we're in a bit of a vicious circle here. Even if we do get moisture, then there's that much more vegetation that then becomes tinder dry in the summer. The only way to break out of that would be to get more moisture in the dry season. And this year there was virtually none. There is actually a normal southwest U.S. monsoon pattern, which simply brings in some subtropical moisture or tropical moisture from the Pacific and occasionally from the Gulf of Mexico, and that can move up into the southern Rockies and even into southern parts of Arizona and California. But that was completely blocked by high pressure. So if the summers keep getting hotter or stay as hot as they have been, and the jet stream is farther north or the storm track, and you can't get moisture in during the dry season, even sporadic moisture, you've got a problem. Secondly, if you stretch out the dry season because of climate change. In other words, it dries out sooner in spring. I mean, a place like Las Vegas, I don't think have had rain in 6 months. Some places it's been April, some places early May. Without rain, that's not a good situation. So the longer dry seasons, the hotter dry seasons, and that has to do with a slightly northward shift of the storm track, which is directly related to climate change. I don't know what changes that, but random variability can do that. Sometimes we'll just get a Pacific hurricane that pushes moisture into California and Arizona in August or September, and that can certainly alleviate things. What's going to alleviate the current situation is good news. Finally, there's still quite a few active wildfires, several dozen, I believe, but rain is moving, wet weather systems moving into the Pacific Northwest, consistent with the La Nina pattern, kind of where we started, which allows more Pacific moisture. Finally, now that we're entering the wet season, but this looks substantial all the way down to northern and central California, but also across the northern Rockies, rain and, of course, the usual mountain snows. So there should be a significant break, and then these storms simply become more numerous anyway after early to mid-November. So the worst is definitely behind us this year as far as western wildfires. But even if we have a wet winter, which is more of an El Nino, and that's not going to happen this year, even that doesn't solve everything. It doesn't hurt by itself. It restores the moisture balance in California, but actually it produced more vegetation. But then if you stretch out the dry season, then you have more dry fuel, which is the opposite of what you are, more fuel rather, in terms of dry or dead vegetation come September and October. And this year everything peaked early or got ramped up early because of that thunderstorm complex off the coast of California in August, hence the term August complex fire, which was California's worst on record. I believe all told over 8.5 million acres in the United States had burned. There were probably more than 900 major wildfires. I mean, the numbers are staggering. And this has been a recurring theme in recent years. Not every year, but most, or many since 2016 in particular.
Wow, yeah, those are definitely some staggering numbers. And yeah, hopefully it's a complicated situation from what you described, but hopefully it is getting better. So I just want to say thank you so much, Ben, for all your wonderful information, your presentation, answering the questions and everything. We really appreciate it. And thank you everyone for joining us this evening. If you have anyone who may be interested in this talk, we are going to put the video up on our YouTube page, as well as the audio on our programs page. So that will be available hopefully in a few days. And yes, thank you so much for joining us this evening.
Yeah, and I want to thank each and every one of you guys who came in to listen, and of course, for those who are listening to this ultimately on YouTube. I just love the interaction, and Jeff for all your work, and we've known each other for years, and from programming. And I'm easy to find under Ben Gelber on Facebook. If you have any real specific questions, especially in this day and age where I can't get out the way I used to, but I take viewer questions or all the time, or maybe you send me a cool picture of a rainbow, or have a question about a cloud formation or a science story. So we have many ways to stay in touch going forward. And thank you all for joining in.
Yes, yeah, thanks again.
Have a good night. Be safe.
You too.